Good morning, grade 9 students. In this video, we're going to make an application on chapter 5, DC voltage. So if you please, you have to prepare a notebook and a pen. And if you please, you have to pause the video whenever you read a question, just to write your own answers before getting it in this video. It would be helpful if we start by making a quick revision. Electricity is of different types, however, we were interested in studying current electricity. In this chapter, we have seen what an electric circuit is, and we studied also generators and receptors. Generators and receptors could be connected in parallel or in series. Concerning current electricity, we were interested in studying the direct current voltage. Once we talk about voltage, this means that we're talking about the pushing factor, the pushing force that leads to a flow of electrons, so we talk about current. Voltage is represented by U and measured in volts, and current is represented by I and measured in amperes. Concerning the instruments used for measurement, to measure the voltage we use a voltmeter, and to measure the current we use an ammeter. Concerning the laws, voltage is additive in series grouping, while current is additive in parallel grouping. Voltage is the same in parallel grouping, while current is the same in series grouping. By this, we are ready to start our application. First, you have to read the given and observe the adjacent document. Pause the video and take your time. So, we have an electric circuit with a dry cell that delivers a constant voltage of 12 volts. We have a switch, connecting wires, and two appliances, a lamp, and a motor. Starting with the first situation, switch K is opened. The first question is, how are the lamp and the motor connected? It's a very simple and easy question. Yes, they are connected in series along the same single path. Now you have to determine the voltage across the terminals of the switch, the lamp, and the motor. Pay attention, the switch is opened. Take your time and write your own answers. So, the voltage across the open switch is equal to that of the dry cell, which is equal to 12 volts. Concerning the lamp and the motor, the voltage is 0 because the circuit is an open circuit. Let's move to the third question. What is the value of the electric current in the circuit? Although we have a generator, however, the circuit is an open circuit, so the electrons cannot flow, so the electric current is 0 since the circuit is opened. Let's move to the second situation where the switch K is closed. Here we have a given concerning voltage. The voltage UBC, which means the voltage across the terminals of the motor, is equal to 7 volts, and the current which is sent by the dry cell is 100 milliamperes, so this is the main current. Let's start with the first question. You have to determine the voltage UPD, UDA, UAB. UPD is the voltage across a closed switch. UDA is the voltage across a connecting wire. UAB is the voltage across the lamp. The first two, UPD, which is the closed switch and which acts as a connecting wire, the voltage is 0. UDA is equal to 0 because it's the voltage in a connecting wire. Since we are asking about a component which is present in a circuit where the components are connected in series, so we have to think about the law of additive voltage. Because of that, UPN is equal to UPD plus UDA plus UAB plus UBC and finally plus UCN. The second step is to substitute the known values. We know that PD is 0, DA is 0, CN is 0, connecting wires and a closed switch. Concerning AB, this is the unknown voltage. We know that the main voltage is 12 and UBC in the given is equal to 7 volts. So let's substitute. Finally, we can get UAB, which is the voltage across the lamp and which is equal to 5 volts. Now the question is about the current which is traversing the lamp and the motor. Think about the laws related to current and keep in your mind that in this circuit the components are in series. So yes, according to the law of uniqueness of current in series grouping, the current that is traversing the lamp, the current that is traversing the motor is equal to the main current, which is 100 milliampere. Now we have to draw on this circuit a voltmeter that measures UCB, and don't forget to show the COM terminal, even if we didn't ask about it. You have to put it on the diagram. From the name UCB, this means that B is connected to the COM terminal. Because we're asking about a voltmeter, then it should be connected in parallel across the motor, UCB. So B is connected to COM. Now, what would be the reading of the voltmeter justify? First of all, we are measuring the voltage across the motor, and we have seen that it's equal to 7 volts. However, we have to think also about the sign. Because B is connected to COM and B represents the positive terminal, then the reading is going to be negative. Keep in your mind that UCB is equal but opposite in sign for UBC. Finally, we have to draw on the diagram an ammeter that measures the current in the circuit when it indicates a positive reading. An ammeter should be connected in series, and concerning the position of COM, it should be connected to the negative terminal in order to get a positive reading. Here it is. This is the symbol of an ammeter A. This is COM connected to the negative terminal. And now I have to thank you for your attention. Don't forget that this application is needed to solve the first assignment.